Welcome to aminacademy.com. In discrete mathematics, we discuss about discrete probability, some introduction. A discrete probability introduces the likelihood of events with countable outcomes, such as the number of heads in coin tosses or the result of a dice roll. A discrete probability distribution assigns a probability to each possible outcomes where the sum of all probabilities equals to 1 and the probability of any single outcomes is between 0 to 1. In computer science, probability theory plays an important role in the study of complexity of algorithms. In particular, ideas and techniques from probability theory are used to determine the average case complexity of algorithms. Probabilistic algorithms can be used to solve many problems that cannot be easily to particularly solved by deterministic algorithms. In a probabilistic algorithm, instead of always following the same step when given the same input as a deterministic algorithm does, the algorithm makes one or more random choices, which may lead to different outputs. Further, simple discussion will continue. Discrete probability deals with the likelihood of an outcome for a discrete random variables which can only take on a countable, means finite number of values. It represented by the probability mass function which assign a probability to each possible values. The key conditions for a discrete probability distribution are that each probability must be between 0 to 1, that is 0 chance to 100% chance. Look at these some examples of a discrete probability includes outcomes of coin toss heads or tails. Look at here, suppose outcome is possible outcome is tossing a coin equal head or tail. These are possible outcomes. Now chances of to get head, that is we can say probability of head equal how many heads? One head. How many outcomes? Two. That is like probability of tail also same way. The rolling of die, that is 6-face die, the outcome is 0, 1, 2, 3, 4, 5, 6. Suppose what is the probability of getting even number? Even number among these outcomes. Look at here. How many even numbers are there here? 2, 4, 6. So totally 3 even numbers out of 6 number outcomes equal probability is half. Next example, number of heads in multiple coin flips possible. The number of students absent from the school on a given day means total number of students is the sample. So the number of students absent divided by total number of student is a probability of an absent student. Next, this scenarios involves countable and distinct outcomes from finite or countably infinite set of possibilities. Now let us deal with some more examples. Look at here. Here are some key points. Discrete random variables. What is that? A variable that can be only take on a countable number of distinct values, often whole numbers. Probability of distribution, a table of or graph that lists all possible outcomes of a discrete random variables and their corresponding probabilities. Properties of a discrete probability distribution, the probability of each outcome must be between 0 to 1, that is both inclusive. The sum of probabilities for all possible outcomes must be equal to 1. Outcomes must be mutually exclusive, meaning they cannot happen at the same time. For example, if you flip a coin, it is not possible to get at same time head or tail, head and tail. So we can get only head or tail, but both at same time we cannot get. Look at here. Now rolling a single die. Yeah, single die. What are the possibilities outcomes? We know we talked about 1, 2, 3, 4, 5, and 6. 6. Then getting probability of getting suppose odd number equal getting odd number equal how many odd numbers are there? 1, 3, 5. 3 odd numbers. Total number is 6. So it is the probability chance is half. Probability of prime number. Prime number. How many prime numbers are there in this? Tell me. Here 2, 3, and 5. Here also 3 prime numbers. Divided by total number is 6, so it is half. These are the simple cases. Getting each number, so the probability of getting 1 is 1 by 6. Probability of getting 1 equal to 1 by 6. Probability of 2 also 1 by 6, like all. Then summing up all the probabilities, we have 1, we have 2, we have 6 equal 1 by 6, 1 by 6, 1 by 6. How many 1 by 6? There are 6 1 by 6 are there. 6 divided by 6 equal to 1. Full probability. Now, further we'll discuss in next videos onwards about some interesting fact about discrete probabilities and solving problems. If you have done, please subscribe our YouTube channel.